Welcome back, and we're going to start on with atomic theory. We did this yesterday, and everyone, here we go. Uh, an atom is the smallest particle of the element. This is the stuff that we learned in Science 9, and that if you chop it up, it's still going to be more atoms. And once you got down to just the one atom with all the circles on it, all that, and if we cut that in half, it just breaks apart into neutrons, protons, and electrons, and it's not an element anymore. And the size of atoms are about, well, they're really tiny. You have to have about 50 million of them to make 1 centimeter. So about 5 million will be the width of your hair, a diameter of your hair. Okay, and atoms are made up of protons, neutrons, and electrons. And then we join atoms together to make compounds. And that's what we're going to be studying quite a bit in Science 10, are the different compounds. And we need 2 or more atoms to make a pure substance, and that pure substance is the compound. So oxygen and hydrogen bind up in a particular way to make water, 2 hydrogens and 2 oxygens. The oxygen is actually quite a bit bigger, and the 2 hydrogens actually bond at the top, so it almost looks like a Mickey Mouse. Okay, and those are the 2 hydrogens and the oxygen. Okay, a chemical change occurs, and we're going to be studying a lot about chemical changes, occurs when we rearrange these atoms to form different compounds. We went over this, that the atoms are made up of protons, neutrons, and electrons. The symbol for a proton is P, the symbol for a neutron is small n, and the symbol for electron is that. Sometimes you'll even see P plus, N 0, and E -1, because they're putting, or E minus, because they're sometimes putting in the charges there. The location of the protons and neutrons are in the nucleus, and the electrons are orbiting or are around the nucleus, way outside. And the relative masses are these, meaning if an electron weighed 1, you would have to have 1,836 electrons to equal the weight of 1 proton. So a proton is much, much heavier. And then if you observe, if we add 1 to the proton, we actually get a neutron. A neutron is just slightly heavier. And if we look at the arrangement of the atom, the nucleus is where all the mass is, right? The nucleus has both protons and neutrons in it, and the electrons are way out there, and they're orbiting around. So the nucleus is basically where the mass is. But funny enough, pardon me, funny enough, the nucleus is so tiny that if we blew it up to the size of like a basketball, if we blew up the nucleus to the size of a basketball, the electrons would be so far away, they'd be like in Ladysmith and Chemainus, that far away. And what surprises me is what's here in between? Literally nothing. An atom is empty. And all the mass is right there, because it's protons and neutrons that are there. And all this is empty, and then the electrons are there. And the next atom would be here. So we could fire a proton. If we took a proton away from an atom and just add a proton, we can fire a proton through material and it won't hit anything because most of this is empty. That's kind of weird to think about it. That mass, particles, the desk is mostly empty. So the nucleus is at the center of an atom, and it contains protons and neutrons. Electrons are orbiting. And the number of protons and the number of electrons are equal in every atom because the charge on an atom is 0. The charge on an atom is 0. So that means the number of positives has to equal the number of negatives. The nuclear charge, the charge inside on the nucleus, is how many protons there are. and that's called the nuclear charge. And the atomic number is the number of protons and the number of electrons. Okay, could be the protons, could be the electrons. So let's see this in action. How do we read a periodic table? You don't have this slide. This is a memory from Science 9. So if we have on the periodic table, which you already understand, but if we have just a single cell of the periodic table, the number at the top is the atomic number. Okay? Now, some periodic tables don't have it at the top, but when you see it, there'll be number 5, and then number 6, and then number 7, and then number 8. They're just whole numbers. That's going to be the atomic number. And the periodic table is arranged by atomic numbers. And that's going to be the number of protons in that atom. So carbon has 6. 6 is the atomic number. So that means that's the number of protons there are. It is also the number of electrons that carbon has. Now there's going to be an atomic mass or atomic weight on there, and that's usually in decimals. Okay, and it really is the number of protons plus the number of neutrons, and we round it. In Science 10 right now, we're going to round it. So if it says 12.01, we'll just write down 12. If it said 18.6, we would make it 19. So the number of neutrons is going to be this number subtract the other number. The atomic mass, the bigger number with decimals, and I'll put a dot there to remind you that it's the decimal one, subtract the atomic number or the number of protons, the smaller number. And that's going to give you the number of neutrons. Why? Again, let's just see if you understand it. This is neutrons and protons together, and this is just protons. So the difference between them is the number of neutrons. And occasionally, and most often with the periodic table, up in the top corner is going to be what they call the ionic charge. And we need to know that as well. So here's a practice. Just on the side of your sheet somewhere, on the second page, before you get to the third page, just write down 7 numbers. We have an element here. I want you to figure out how many protons, how many neutrons, how many electrons, what's the atomic mass, the number of subatomic particles, the atomic number, and the number of subatomic particles in the whole atom. So just check it out, see if you can do this. This is from a quiz in Science 9 that I had. Okay, let's answer these now. The number of protons. The number of protons is this number up in the top left. The number of neutrons will be the bigger number, subtract the smaller number, and that's going to be 19.0, subtract the 9, so that's going to be 10. The number of electrons in the atom is the same as the number of protons. It has to be the equal charge, so this is going to be a 9. The atomic mass is the bigger number, and that's going to be 19. The number of subatomic particles in the nucleus. That means the number of protons plus the number of neutrons. Because in the nucleus, that's the protons and neutrons. And by the way, the number of subatomic particles is these two, which is also the mass. So it'll be 19. If you wanted to do it, you could add up the 9 and the 10. The atomic number is the number that's up in the top, 9, because that's the same number as the electrons and protons. And the number of subatomic particles in the atom, in the whole atom. So that's the protons plus neutrons plus electrons. And that will be these two numbers added together, which will be 28. So hands, how many people had 7 out of 7? Okay. Not as high as I'd want. Maybe some people can't raise their hands. So that's a bit of practice that we need to go over a little bit more. Let's start on some new notes today. Now, this lesson that we're starting here, this slide, is going to come up with terminology that you might be familiar with, but if you're not, don't worry, because the next slide is talking about where all these things are and what they are. Okay? Which is slide 4, not slide 5. So here we go. The periodic table of elements are listed in order by atomic number. So it's number 1, then number 2, then number 3, and then number 4, and then number 5, and then number 6, which is that carbon one, all the way up to number 9, which is that fluorine one that we just talked about. Metals are on the left, and the transition metals are in groups 3 through 12. Nonmetals are on the right. Metalloids form a staircase towards the right side. Rows on a periodic table are called periods. And all the elements in a period have their electrons in the same general area around the nucleus. So there's some new words here. Periods. We have metals, nonmetals, metalloids, and transition metals. We need to eventually know where they are all located, but we're just learning what they are, and then the next slide we'll be talking about where they are located. Columns are often called groups or the same thing as families. Same. They have two different names. And all elements in a family have similar properties and bond with each other in similar ways. And there are four families that you need to know by name. And they are alkali metals, alkaline earth metals, the halogens, and noble gases. And sometimes they call group 17 actually just group 7. And sometimes they say group 18, sometimes they just say group 8. I'll show you why. So you need to know where the alkali metals are, the alkaline earth metals, the halogens, and noble gases. Okay, so we're going to come up to a next slide here, which is the periodic table. It's your full-size one in your handout. So I have slides 4 and 5 rearranged so you can sketch over this. So I do expect you to be sketching all over this. This is not going to be something you're going to use on a test. This is what you're going to be using to study with, just where these things are. And I have animations showing up here. Just take a quick peek, right? I have arrows popping up. I have I have boxes showing up, and I have arrows showing up. So eventually you're going to be sketching all over this. This is going to be quite a mess if you're doing it for you to study with. So here we go. Where are the following? The atomic number, the first thing up here that we're going to look at, the atomic number is in the top left of the corners. So if we take a look at potassium here, following my cursor here, if we can, potassium, it has an atomic number of 19. A period is a row. So we have a row going across, and this is the second period, the second row. We have the first period up here, the second period, this is the third one, this is the fourth one, this is the fifth one, this is the sixth one, and this is the seventh period. So I should be able to tell you if element 37 is rubidium, what period is it on? And you should be able to tell me it's on the fifth period. Okay, Ethan? Group numbers. These are verticals. And vertical columns are called groups or families. So this is the second group. How do you know it's the second one? Well, it's labeled on this one. This is number 2. This is why over here we have 17 here and we have 18. 18th is the last one. Okay, metals. Metals are anything, follow my pen here, all these are metals. Anything to the left of that zigzag staircase thing down this middle. Non-metals. That's the other side of that zigzag staircase. So you're doodling all over this. You're doodling all over this, whatever you need to do. And the transition metals, I have a problem with my graphic here. Watch where it comes in. My graphic is too far over. These are the transition metals, right to there. So I have group 13 and group 14 highlighted as well. They're not transition metals. So I do have a problem with my little animation here. Why don't I fix it? I don't know. I could do it every year. Last but not least, locations on the table is the metalloids. Metalloids are the staircase. So once again, here we go. Alkali metals are the first column. Alkaline earth metals are the second column. Special names for those column families or groups. The second to last one is called the halogens. And the last ones are the noble gases. Okay, so they're family number 1. This is family number 2. And halogens family number 17. And noble gases is 18. Okay? So we're going to talk about ions here. Atoms gain or lose electrons, and they do that to form bonds. Atoms become electrically charged. When they lose an electron or gain an electron, they don't have an equal number of protons and electrons. The protons they don't lose. So if they gain an electron, they have more electrons, so they'll be negatively. And therefore they become negatively charged. And when something doesn't have the same number of protons and electrons, they're called ions. Important term. They're either atoms, and that's when the protons equal the electrons, or when the protons don't equal the electrons, they're called ions. Now, we're going to talk about metals and nonmetals and how they're different. So, metals, they lose electrons. And when you lose electrons, that means you have less electrons than protons, so there's more positively charged items in there, more protons, so it's going to be positive ions. And another name for positive ions are cations. Positive ions. Now, some metals lose electrons in different ways, and they're called multivalent. For instance, we have iron here. Iron can lose 3 electrons to make it positive 3, or 2 electrons to make it positive 2. So they can do it in different ways. So that means iron is multivalent, manganese is multivalent, and cobalt here is multivalent because you can see that there's a plus and an on them that are all different. But these metals over here, they're not multivalent. They have only a single ion charge. So the numbers up at the top are ion charges. And these are metals. So this guy will lose 1 electron because it becomes positive. This guy will lose 2 electrons because he's positive 2. This guy will lose 3 electrons because it's positive 3. And these are, as I said, these are multivalent. Because they can lose 2 or 3 in iron, or even manganese has 3 ionic charges that are possible. So for example, as I wrote in the notes here, it either loses 2 to become Fe plus 2 or Fe plus 3 for iron 3. Nonmetals gain electrons, and by having more electrons, you become a negative ion, And another name for a negative ion is an anion. An anion is a negative ion. Negative. Has more electrons. So this one has oxygen here, has a -2 charge, so gained it has gained 2 electrons, because then it has 2 more electrons than the protons. The protons don't change. Oxygen always has 8 protons. Fluorine. Fluorine here has 9 protons, but when it's an ion, it'll gain an electron because it's a negative, -1. But neon here has a 0, meaning it's happy. It doesn't take on and therefore an electron, or doesn't lose an electron, so it doesn't become ionized. There's no ionized charge. Atoms gain or lose electrons in an attempt to have the same number of valence electrons as the nearest noble gas. Okay, let's just, I review that one weird sentence there that I have there, that I just copied that over here. In case you need to copy it down, it's still here, but it's now on here. So, no, I didn't want to do that. So if we have an atom and we have oxygen, sorry, let's go back. We have oxygen. Oxygen has 8 protons and it has 8 neutrons. And if it's an atom, therefore it'll have 8 electrons. So in the nucleus, we have the 8 protons and the 8 neutrons. And that's the nucleus. Around the nucleus, we will have 8 electrons. But if we go back here, this is the periodic table. If we go 2 over to the right, this is a noble gas. That's a noble gas. Neon is a noble gas. And it wants to have the same number of valence electrons. So it wants to have 10 electrons because the noble gas of neon has 10. So it's going to gain 2 more electrons. And if it gains 2 more electrons, it's going to have a total of 10 electrons. So an ion of oxygen has 10 electrons. How do you know? Well, it says it's going to have a charge of -2. If it's negative, it's going to have more electrons. How many more? 2 more electrons. 2 more than the 10, than the 8. So it makes it 10. And it just so happens that everyone that ionizes wants to be like the neon. So the fluorine will gain 1 to make it look like neon. And there's another term here that we're just learning? Valence electrons. And these are the electrons furthest from the nucleus. So that's another term here that we need to know. Valence electrons. These are the ones furthest from the nucleus. Now, we're learning everything here step by step, and some of these terms are new to you. So it's confusing, but once we get it all together, it'll click fit like a perfect model. And then we'll understand valence electrons, we'll be understanding everything. So a lot of this stuff is new. Let's go to the 6th slide. Is that the last slide? Nope. Bohr diagrams.